All right, today we're going to be learning the final type of transformation. So far we've learned about translations, reflections, and rotations. Today is all about dilations. So a dilation is a non-rigid transformation, and what that means, it changes the size of the shape. Okay, so it's not going to change the actual shape. It's not going to go from like a triangle to like a circle. It's going to go from a bigger triangle to a smaller triangle, or vice versa. Okay, just like we did before, we've got pre-images and images that had those little notation that say like primes. And here's how we change it. If k is larger, then k is the scale factor. If k is larger than 1, that means it's going to get bigger. And if k is somewhere in between 0 and 1, it's going to be a reduction, or it means it gets smaller. So an example is if it has a scale factor, a k value of 2, it's going to get 2 times bigger. If it has a k value of 1/2, it's going to get half the size, or we're going to make it half as small. We often have this notation for it. So D just means dilation. P is the center of dilation, where you're kind of doing everything from, just like we did with rotations, we have a center we focus on. And K is the scale factor. All right, if it's listed as an O, that just means it's going to be around the origin. So let's do some examples here. So example number 1. All right, it says a dilation of O, which means it's around the origin, 0, 0. A scale factor of 2, so that means it's going to get 2 times bigger. So what I do here is, smaller, we're going to put an X on the center of dilation. So the center of dilation is 0, 0, so that origin. And what we're going to count how far away each of those points are, and we're going to make those distances 2 times as big. So for example, point A here, to get to A, I go up 1, over 1. All right, so since I go up 1, over 1 to get to A, I'm going to make those 2 times bigger. So I'm going to say that they're going to go up 2 and over 2. So I'm going to go up 2, 1, 2, over 2, 1, 2. And that's where my new point A is going to be. And we're going to call that A prime. We're going to do the same thing for B and C. Now for point B here, point B, it goes over 2, 1, 2, so to the right 2, and down 1. Okay, so I'm going to make those distances 2 times as big. So instead of going to the right 2, I'm going to go to the right 4. Instead of going down 1, I'm going to go down 2. I'm going to go to the right 4, 1, 2, 3, 4, down 2, 1, 2, and that will be where B prime is. All right, and then finally for C. C is to the left 2. So we're going to make that 2 times as big. So we're going to say to the left 4. So 1, 2, 3, 4. And we're going to call this point C prime. Once you have all your points, you're going to connect them. And there's my new triangle. And you'll notice it did get bigger like we thought it would. All right, let's do another example here. This one says around A, so our center of dilation is point A, so I'm going to put an X on point A, which means point A will not move. It has a scale factor of 2, so it's going to get 2 times as big. So since point A won't move, let's go to B first. B, I'd go to the right 1 and down 2. So I'm going to make those 2 times as big, so I'm going to go to the right 2 and down 4. So right 2, 1, 2, down 4, 1, 2, 3, 4. And that's where B prime will be. For point C, I go down 1 to the left 1, 2, 3. So we're going to make those distances 2 times as big. So I'm going to go down 2 to the left 6. So down 2, 1, 2, left 1, 2, 3, 4, 5, 6. And that will be C prime. Since A didn't move, this will now be A prime. So we're going to connect our dots. And there is my new triangle. All right, last one here. It says dilations are on 0, 3. So I'm going to go to 0, 1, 2, 3. So my center of dilation is right here. And we're going to do 1/2. So it's going to get smaller here. All right, so for A, I'm going to use some room. For A, from this center to A, we go down 2 to the right 1. Down 2, 1, 2, to the right 1. Okay, so I'm going to double both those. I'm going to go down 4 or sorry, not double, I'm going to halves them, my bad guys, since we're doing it by 1/2. So we're going to take 2, we're going to divide it by 1/2. 2 divided by 2 is just 1. Instead of going to the right one, we're going to times that by 1/2. So we're going to go to the right 1/2. So we're going to go from this origin, we're going to go down 1 over 1/2. And we get A prime. Up next is B. So to get from my center, I go down 1, 2, 3, 4. I go down 4. And I go to the right 2. So we're going to take those values and we're going to multiply it by 1/2. So 4 times 1/2 is 2. 2 times 1/2 is 1. So we're going to go down 2, 1, 2, to the right 1. And that will be the new B prime. And finally for C we go down 3, left 2. So we're going to multiply those both by 1/2. So it'll be down 1.5 and left 1. So I'm going to go down 1 1/2 and to the left 1. And that will be C prime. I'm going to connect my dots. And there's my new triangle. Okay, so that's essentially how we do these problems. Now we're going to do one more here. It's quadrilateral, same idea. It says the center of dilation is at 0, 0. So we're going to put an X on 0, 0. We have a scale factor of 3/2. All right, so you might want to get your calculator out for this to help us with some of those multiplication facts there. So let's start with point A first. So from my center to point A, I go to the right 2. So what you're going to type into your calculator, you're going to do 2 times parenthesis 3 divided by 2, and I get 3. So for A, I'm going to go to the right 3. And that'd be going over 3/2. For B, I go down 2. So I'm going to take 2 and multiply it by 3/2 again, and I get 3. So I'm going to go down 3. 1, 2, 3. For C, I go up 1 and then to the left 2. So for up 1, I'm going to take 1 times it by 3/2, which would just be 1.5. And then I'm going to take 2 times 3/2, which is 3. So I'm going to go up 1 1/2 and then over 3. And that will be C prime. All right, up next we've got D. D, I go up 2 to the right 1. I'm going to times 2 by 3/2 and I get 3. I'm going to times 1 by 3/2 and I get 1.5. So I'm going to go up 3 over 1 1/2. And that's where D prime is. I'm going to connect my dots. And there is my new quadrilateral. All right, so that's how to actually do the dilations and change the shape. What we're also going to study today is how to go from the two shapes and figure out what the center is and what the scale factor is. So we are going to need some rulers. All right, so this one tells us that we need to determine the center of dilation and the scale factor, and that the image, so our brand new shape, is the dashed triangle. So to find the center first is what we're going to take corresponding points and draw lines through them, and we're going to see where all those lines intersect. So here's an example. This top point right here and this point right here are corresponding points. They kind of go together. So we're going to draw a line between those two using our ruler. Okay, so there's our line. We're going to do the same thing with the other point. So I got this point matches with this point. Let's draw that line. And then finally our last one. I'm going to connect those two. Okay, and you'll notice all of our points are meeting right at that point there. And that point right there is -2, -2. So our center is -2, -2. Now here's how we find our scale factor. You're going to find the closest point to that point. So I'm going to say this is our center of dilation. The closest points are these two corresponding points. Now you're going to do the dash or your image over your pre-image. So my image is the dashed one. So if I look at this one, for the dashed one, I went down 1 over 1 to get there. So I went down 1 to the left 1. For my image, I went down 2 over 2. So I went down 2, left 2. So look at that. I have my scale factors right there. My scale factor is 1/2. And you look at that shape. The shape goes from that big shape to that smaller triangle, so it does make sense. Let's repeat that process. Again, we're going to draw our lines first to find the center. So here to here, we're going to draw a line. Okay, these two correspond. And finally, these 2 points match up. All right, so they're all converging at this one point right here, and that point is 0, -2. Now to find the scale factor. I think the closest points to this origin or center of dilation are right here and right here. So for those points, I want to do my image over my pre-image. My image is my new one. My image is the one way out here. So my image is 1, 2, 3, 4, 5, 6 away. My pre-image is 1, 2, 3 away. 6 divided by 3 is 2. So it's a scale factor of 2, which makes sense because our dashed triangle is much larger than our original one. All right, we're not going to do the next one. Okay, but there's 2 answers of that one. All right, some things here. This next one, this is some OST prep. This is a commonly asked question on the OST, and it's talking all about equations of lines, all right, and how we dilate a line. Dilating a line isn't that bad. When we dilate a line, the slope stays the same. Okay, the y-intercept changes. So for example, the first one says, given the line y equals 1/4 x plus 1, we want to dilate it by a factor of 3 using the origin as the center of dilation. So we know that our equation line is going to start off with this, y equals 1/4 x. So the slope's going to be the same. What's going to change is this, the 1. So let's graph this. If it has a y-intercept of 1, that's right here right now. It says the center of dilation is the origin, so right here. So right now, from the center of dilation to that point, I have to go up 1. What we're going to do here is we're going to be dilated by a factor of 3. So we're going to take that 1 and multiply it by 3. So we're going to go up 3. So starting at my origin, I go up 1, 2, 3. So my new y-intercept should be plus 3. Okay. So dilating line, it's not going to change the length of it. It only changes the y-intercept. Changes. Okay. Next one here, it says it has an equation of y equals -2x plus 8. We're going to dilate it by a factor of 1/2 with a center at 0, 0. So let's see if we can do this one without using the graph. So we know it's going to be y equals -2x. Okay. Now, if it's the center of 0, 0, and we start at 8, currently, those are 8 units apart. We're going to take that and we're going to times it by 1/2. So 8 times 1/2 would be 4. So we want them to be 4 away. So if I go from 0, 0, and I go up 4, it'd be plus 4. All right, same problem here. Same scale factor, but just a different center. So for this one, it's going to be y equals -2x plus something. Right now, 8 and 6, well, those are 2 apart. So we're going to take 2 and times it by 1/2, and we get 1. So you want to go 1 away from 6. Well, 1 away from 6 is 7. And that would be your final answer.